Okay, hello people. Welcome to the first pre-calc video lesson. You're gonna have like a series of 4 or 5 of these heading to the final. So let's go ahead and just work out 8R here. This is a nice pre-setup that you can kind of see here. Of course, I'm gonna do these pre-setups and then you'll see all the answers later on when I scan into the website, but this is just a pre-setup for the video here. You might want to just get this down so I can explain it. And then you can pause, of course, so you can view it closer. This is all the nice setup for all this. I'm going to pass this out for today, 8R. So let's go ahead and get started. Now for the first one, they just gave you a simple, nice right triangle, a nice theta for your angle A. And you want to get all the other trig ratios, the 6 trig ratios. So you want to label opposite, adjacent, hypotenuse, and then you go ahead. SOHCAHTOA is pretty straightforward, but then the new ones will come along as well, you'll see. So for the first one, sine, of course, is going to be 5 over 13. So 5 over 13. And then, of course, the reciprocal of that would be then 13 over 5. So that's how they're related. Here, cosine would be 12 over 13. So 12 over 13. And then this one is, of course, going to be 13 over 12. You get the idea. Go ahead and finish tangent, cotangent, no problem, opposite over adjacent. Okay, let's move on to this one here. So here they also want you to get the other 5 trig ratios, starting with that one. Now, one thing that I wanted to make sure you understand, all these 3, we're all pretty good experts on. Check. This is a bit new, right? But you use these old ones, these original 3, to help you understand these 3. This is what I mean. So if you ever have something like the cotangent of theta equals 11 over 3, you want to convert that to 1 over tangent equals that, and it actually comes out to tangent theta equals 3 over 11. This makes sense because it follows this and this. Like if it's something here, it's the reciprocal there. So then when you're here, you want to make sure to solve for C for your Pythagorean theorem there for that last thing, and then you do the same thing that we did here for these 2. You kind of have space to put them all here and as well here. I made a little mistake here, so no problem. Same with this cosecant. You have 12 over 5. You convert it to its identity, reciprocal, and then you get the sine of theta equals 5 over 12, and then you label that. This is A or B for Pythagorean theorem, so you're going to solve for that. Let's just label it A, and it'll be 12 squared equals A squared plus 5 squared. Once you get that other side, same thing as the first one. Okay. Now this is the one I'm really interested about here. Questions 4 through 9. Evaluate each without using a calculator. When they say that, and a lot of times in trigonometry, it is only the unit circle. The unit circle are filled. All those coordinates of the unit circle, they're all solutions to trigonometric equations. So let's go ahead and start. And actually, one thing that you got to get used to is how to read something like this and how to give yourself a nice quick little unit circle and figure out the answer by doing that. You have to do that because it's not as easy. You can't really picture unit circle. You have to draw it in, and you have to know the little parts it's talking about. Okay, so let's get started. So the sine of pi over 3. You're saying, since it's sine, you're going to be thinking y coordinate. What's the y coordinate of the angle pi over 3? Well, we kind of draw a unit circle here. Pi over 3 is 60 degrees right there. Nice. And we give its coordinate. The y is square root of 3 over 2. So there you go. You answered this question or this little statement. What's the y coordinate of angle pi over 3? Well, that's that. So the answer to this evaluated is this guy right here because we just picked out that y coordinate. So you need to do that again for all of them. Now, for these other trig ones here, so this is right away, right? Sine, tangent, cosine right away. You can do that, no problem. Let's look at this tangent one here. Pi over 4, which is 45 degrees, which is right there. You get these 2. Of course, tangent is this divided by that. So we know that they're same, so that's 1. No problem. When you have these types, you must convert first because it's difficult to think about the unit circle when you have these other 3 trig ratios. But for this, convert. You can do this. This is the y coordinate of pi over 3. This is the sine divided by cosine of this pi over 6, right? So you can use that, and then it'll just be inverted. It'll just be a reciprocal. Once you can solve for that, it's just going to be reciprocal. Same here. This is difficult to do, but once you change it like this, oh, okay, I know how to do this. I just do the same thing I did here. Actually, you know what? This is the, there you go, nice. This is the x coordinate, right? You would say, what is the x coordinate now for cosine of the angle pi over 3? That's right there, 1/2. So look, this guy here then gets solved like this, 1/1/2, which just inverts it to, well, let's do the whole thing. 1/1 divided by 1/2, which is then 1/1 multiplied, 1/1 multiplied by 2/1, and 2 is my answer. So the secant of pi over 3 is 2. Okay, so go ahead and finish that off here. I want to show you the table one now. This guy here, 9L. I'll have that for you today. So for this ones, I want you to set up these. I want you to get all the radians for all these degrees, and of course use a unit circle or your manipulative to give you the x coordinates, the y coordinates, and then the divisions. This divided by that, this divided by that, right? So these are nicely filled out. You can fill out this whole table. This is the first quadrant that I have for you. But look how it works out with the other one. So this is the original sine, cosine, tangent. And then I have this 9R to give you the secant, cosecant, cotangent. So same radians and degrees. But here, it's very interesting what happens. You see, with the first one, the reciprocal is 1. 1/1 is 1. But when you have zeros, this is 0/1. 0 over reciprocal, 1/0, undefined, undefined. You have this one here, this one, square root of 3/2, and you invert it for this, but then you want to rationalize your denominator. Yeah, this is your answer. This, reciprocal, 2. This, reciprocal, square root of 3. And those are the answers for these guys. So you do the original 3 to help you understand these other 3 trig ratios, the reciprocal ones. So same, moving on, square root of 2/2, inverted, right, and reciprocal, rationalize, your answer is square root of 2. Since that's the same thing, that's the answer already, square root of 2. So there you go. And then 1/1 is the reciprocal is just 1. This reciprocal of that is 2. Reciprocal of that is 2/3, but you don't want to leave it like that. You want to rationalize it, right? By rationalize it, you are doing this, right? You are multiplying by square root of 3 over square root of 3, and that will give you 3 at the bottom and 2 radical 3. And then that's your answer, okay? You get the idea. Undefined becomes 0, 1/1 becomes that, and then 0, since it's 0/1, you are of course doing here now 1/0 for this guy, and that's undefined. That's why it's undefined. And then go ahead and finish this off here. There you go, the first video lesson for pre-calc. Thank you. Goodbye.